Hello guys, Edgar Fernandez from Sufficient Limited, located in Brantford, Ontario. Monday. Well, today I want to talk about something that I always read every month. That is the process safety beacons from the CCPS. That means the Chemical Center of Process Safety, that belongs to the American Institute of Chemical Engineers. And normally, each month they generate these beacons, these bulletins with excellent information, with pieces of advices on regarding on to prevent incidents that has happened in the industry. So this time, I want to talk something that was published in March 2017, but it's something that we need to keep in mind. It's here I have it in front of me. It's an incident actually. Processing some solvents, and but they were operating below the flash point actually, and still they have an explosion, a fire. So that occurred in 1986. The explosion, was an explosion on a 10-gallon, approximately 38 liters of agitated diesel in a pilot plant. So they were the thing that the phenomena that was occurring was an oxidation reaction that was being done in a pure oxygen atmosphere at 250 psigs, that it's around 1825 kilopascals. And it was thought that the diesel atmosphere was safe from ignition since the vessel was operating at 50 degrees below the flash point of the contents in the oxygen atmosphere. So the fuel vapor concentration was below the lower explosive limit, the LEL. So they said that the processing conditions were stable for 41 minutes when suddenly the explosion occurred, and it ruptured the 750 psig and the 5200 kilopascal reactor and did a significant damage. So what happened here? Well, regardless of the mixture inside, or the reaction was below the flash point, the phenomena that was occurring was the agitator was created, because this vessel has an agitator inside, was creating pellets or mist, or it's a fine mist of the liquid droplets, right? So obviously with the air, so now you're expanding the liquid, right? So when the liquid is concentrated with the agitation, nothing is going to happen. It's the droplets that they are going to the air. You measure those ones per square meter, or each droplet. The thing that I'm trying to explain is that each droplet had the right amount of concentration. They were above LEL and above splash point in the air. In the reaction, or in the air, that's something different. So each droplet behaves very different. And that's the thing that occurred. The explosion happened. So you have a static, you have oxygen, and you have the temperature, the temperature. So now you complete the fire triangle for that droplet. So imagine that droplet multiplied by 1,000. Or for as many. Actually, the bulletin doesn't say as 1,000, but multiply as many times. So that droplet has the enough concentration of solvent vapor to cause a flash fire, and that's the thing happen. Below, it's like when you have a combustible dust explosion, when you put the dust goes everywhere, and then with the static in the air, that friction creates a flash fire explosion, and then a secondary explosion. Well, that's the same with the liquid when it becomes a mist. So now the mist is going everywhere, and that with the friction of the air and with the oxygen, so you have the fire triangle completed, and the explosion is going to be occurred. What they recommend, well, first, actually they divide the safety beacon into this: did you know, and what can you do? Well, did you know, for example, the mist of combustible liquids drops at temperatures below the flash point of the liquid can be explosive as a fuel, vapor, air mixture? That's the first question. So the explosion mechanism is similar, like I was saying, to the Dox explosion. Is very similar. So now it's like the separation is creating energy, and with the friction, right, a generated static. So you have the combination of the air and you have a combination of the oxygen. So now you have the fire triangle. So in this incident, the mist actually was formed by the agitator that was still near to the liquid surface, generating this mist. And also, the mist can be generated for a leak. If you have a leak on the pipeline as well. So you have the leak, and the pipe is coming, the liquid is coming at high pressure. So now you're gonna generate that phenomenon. So what you can do to prevent these incidents is very simple. They say be aware of the potential of the fire or explosions of a mist of flammable or combustible liquid, or responding to a leak or a spill. Never assume that there is no hazard because the temperature is below the flash point. That's a good point. Observe a mist or a fog inside of any process equipment and inform your management so they can ensure that the proper protective measurements are in place. And promptly report any leaks of flammable liquid or combustible material, including utility fluids that you can see them in your facility. And actually, you have operations for that you are using flammable liquids you are spraying flammable liquids. But first, actually, the NFPA 30, especially for the cleaning process, in the pharmaceutical industry, chemical as well. I'm seeing that don't use the solvents and mix them. It's a big no-no. It's actually a practice that is not recommendable to execute. And also, for you have manufacturing operations that you need to create mist with flammable or combustible liquids. It's something that you need to consult the NFPA 30. So they're gonna tell you exactly. That standard is gonna tell you exactly what you need to do when you have this type of operations. So there are very complicated operations and very, very dangerous as well because the mist. So how we wanna control that? So in this case, I would put an example here in Canada, right? In winter, we have -25, or Western Canada, inclusive -40. So you're operating a reactor in -40 degrees, or your reactor actually is inside. You have a cryogenic reaction that requires -20. So don't assume that the solvent, nothing is going to happen. The solvent as a liquid, a compact liquid, yeah, nothing is going to happen. But with the agitator on the top that is misting this liquid, yeah, something is going to happen. And that's when you have the concentration, you have the LEL above, you have the temperature, and then you have the oxygen. So something is going to happen. So the static with the friction, is something that is going to cause a flash fire. I found this article this beacon very interesting. And actually, something that I said here to make my point is that tiny droplets were estimated to have an average size of about 1 micron. In comparison with the diameter of the human hair, it's 40 or 50 times larger than the mist droplet, right? So they have conducted some flammability testing that they have demonstrated that the mist could be ignited in a room at room temperature in air. And the mist would be ignited even more easily in a pure oxygen atmosphere. Absolutely, because they are expanded, they are all over the place. It's small, so now one droplet ignites, the second one is going to ignite. It's easier because you have this phenomenon multiplied by the several times. Although they said that although it is often difficult to identify an ignition source from an explosion, that could be in static, to be honest with you. So they said that this investigation determined that the most likely the ignition source was a a contaminant left over from the previous experiment in the vessel. Oh, so maybe they have a reaction there. They didn't clean it properly, and then they didn't verify the cleaning, and then suddenly happens. Uh, in the pharmaceutical industry, obviously these issues shouldn't happen because of the CGMPs. So you need to do validations of cleanings, and then obviously during the batch cleaning, you need to do verifications of cleaning, and then needs to be submitted and analyzed, this verification, and then you can say you can produce the next batch, regardless it's different or the same product. Maybe not in this like the chemical industry. Maybe you don't have that type of very strained and very detailed cleaning that that you need to perform, and then these things happen. So always is at least in the chemical, you need to do one verification, and you need to have a procedure. How do you want to verify that that reactor or that mixer tank is clean? If not, you're going to have this type of incidents as well. Appreciate that. Thank you very much. See you tomorrow, and have an excellent Monday. Bye.